Hi everybody, this is Mr. Folly, and welcome to what hopefully is an easier way to do these problems. So what is titration? So here's the worksheet we get to do next. Titration is using a, burette, I guess I have to write smaller or slower, burette to find moles, molar mass, molarity of an unknown. Okay, remember a burette is this thing that looks like this, drip, 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 and it's typically in an Erlenmeyer flask, right? And the color changes. What is a titrant? The solution in the burette. What is the analyte? It is the substance in the flask. I'm going to draw cheesy pictures here. That's my burette. That's my flask. What is the equivalence point? The equivalence point is when moles of titrant equal moles of analyte, which means, remember how we have the MV stuff? It's when MV equals MV, right? And I like to use the X's. What is the endpoint? The endpoint is my favorite point. It's where the color changes. How can you say that, Mr. Foley? You're colorblind. My self-esteem. My self-esteem. Somebody got a calculator. A 0.35 molar solution of sodium hydroxide is reacted with 25 milliliters of unknown molarity of sulfuric acid. It takes 17.3. I'm getting my calculator. All right, I have my calculator. I'm sorry about that. But I'm stuck in a spot where I'm trying to get my calculator to work. Okay, good. So, 0.35 molar solution of sodium hydroxide is reacted with the unknown molarity of sulfuric acid. So, sulfuric acid is H2SO4, which is right here. So that means my X is 2. So determine the molarity of the sulfuric acid. So, XMV equals X, MV. I always put my acid on my left and my base on the right. So, number of H's in H2S is 2. Molarity of sulfuric acid is what I'm solving for. I have 25 milliliters, 0.025 liters. Sodium hydroxide has 1 hydroxide. Oh, my doggy wants me to hold her bone. And the molarity of the sodium hydroxide solution is 0.35. The volume that it took was 17.3. I really dislike that answer. Because, first of all, it's got to be in liters. So it's 0.0173. And we know burettes always give 2 decimal places. So that makes me so sad. Throwing this into my calculator. I lost my drawing. So molarity equals 0.35 times 0.0173 divided by dose divided by 0.025, and I get 0.1211. I don't want to do that. I want to draw 0.121 molar. Okay, and everything I have here's 4 sig figs, 3 sig figs, 3 sig figs. My answer has 3 sig figs. Determine the molarity of an unknown HCl solution if it takes 20 milliliters of 0.75 molar NaOH, that's my NaOH, and I'll find the molarity of HCl, track completely with 10 milliliters again. I want 2 decimal places there, but I guess I have to deal with those. So, same deal. XMV equals XMV. Again, you're seeing my little mind run off, where I just know HCl has 1 H. Looking for that molarity. The volume of HCl is 0.01 equals 1 for OH. The molarity is 0.75. The volume is 0.02. So 0.75 times 0.02 divided by 0.01 is 1.5. And I'm given two sig figs everywhere. So that's it. A colorless solution of hydrogen peroxide is titrated with acidified dark purple solution of potassium permanganate, KMnO4, as shown by the net ionic reaction below. Okay, good. So this is my dark purple one. This turns into pale pink, so I don't need an indicator for this one. The student places 5 milliliter of hydrogen peroxide in a 125 milliliter Erlenmeyer flask, properly fills the beer out with potassium permanganate. Note, at this point, the titration, the solution appears pale pink in color. That's because it's this right here. Describe the appearance of solution as potassium permanganate is added. Explain your reasoning. So what do we have in the bottom part? Color solution of hydrogen peroxide is titrated with. So this is colorless. This is purple. It's called dark purple. It's intense purple. And then this guy right here is pink. Okay. Describe the appearance of the solution as potassium permanganate is added. What will happen is it will be purple for an instant, then go back to pink. So as you add a drop, it's kind of like if you drop something in there, you can tell where it is for just a little bit, and then as it mixes, it goes away. When purple persists, it is the end point. Okay. What in the net ionic reaction causes the pale pink color? Oh, I already did that. It's Mn2 plus, and note it's an unfilled D. Dun, dun, dun. Hey, we've had that an awful lot, haven't we? Particle view of a sample of H2O2 is shown above. The H2O2 is titrated with KMnO4 as represented in the equation above, which the following particle views best represents the mixture, and the titration is halfway to the equivalence point. So that means I should lose, whoops, I put lost. I should lose half the H2O2 and add, let's check my coefficients, please be ones. Oh man, so I'm halfway there, my moles have to equal each other. And add MnO4. So I'm looking at these coefficients and I'm being kind of lazy. So I'm going to lose more than half, right? Lose more than half. Half of the H2O2. And then I'm going to add MnO4. Okay, so let's take a look. So if I'm halfway there, oh man. So it's not gonna, if I'm halfway there, the moles of each one would be the same. Try to ration this one out, which the following particle views best represents the mixture halfway to the equivalence point. So I was really hoping for the 1-to-1 ratio. So this is terrible the way I gotta think through this. So let's take a look here. What if it was 50-50? Let's see if we've got a 50-50 there. So what do I have here? I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 of these. So this would mean that halfway I would lose 5 H2O2s and I would add 2 MnO4s. That's Mn plus 2s, right? I said MnO4s. Add 2 Mn plus 2s. Because that's the coefficients. Okay? Halfway, I'm starting with 10, I'll lose 5, so I'll have 5. So that means I'm looking for 5 and 2. 1, 2, 3, 4, 5, 6, nope. 1, 2, 3, 4. Nope. 1, 2, 3, 4, 5. 1, 2. C is the answer. Okay. So again, what I did was I looked at the coefficient. This says it's going to be 5 and 2. So if I started with 10, halfway would take me to 5, right? And if 5 of these were lost, 2 of those were used up, but really I'm looking at the wrong ones here. I'm sorry. 2 of these would form. Okay. So if 5 of these go away, if 5 H2O2s go away, oh no, I don't want cookies. Oh no, I don't want cookies. I lost my thing. Oh well, I guess I'll stop it. And we will pick it up from there. Toodles.